Hello, Math Analysis. So here's a video of the review to help you prepare for the test. Something we should know to start off with is when you're doing your inverse cosine, a positive ratio comes from the first quadrant, a negative ratio will come from the second quadrant. Also, you're going to want to remember that in a 30, 60, 90 triangle, this would be, 60 would be up here, sorry, to erase this, and my 30 would be right here. So 30 is opposite the 1. If you see rad 2 over 2, that is the rationalized version of your 45, 45. So those are the values you want to keep in mind. And so again, the definition of arc cosine is plus or minus whatever the value of the inverse cosine is. So you always want to evaluate that, plus 2 pi n. All right, so let's get into it. Arc cosine rad 3 over 2. It's in the first quadrant. So if you're not sure what goes with that, my adjacent is rad 3, hypotenuse is 2, so the opposite is 1. So this gives me a 30-degree reference angle. So this will be plus or minus 30 in radians is pi over 6, 180 divided by 6, plus 2 pi n. If I'm doing the arc cosine, it's negative rad 2 over 2, which is your negative 1, 1, rad 2. That's your 45 degree. But getting over here is 135. So this will be plus or minus 3 pi over 4 in radians, plus 2 pi n. And then we have inverse cosine of negative 1. Well, on the unit circle, remember cosine is the x value, so that's going to be at 180. So this will be plus or minus pi plus 2 pi n. And lastly, we have here arc cosine of 0. Cosine is 0 at 90 degrees. So this will be plus or minus pi over 2 plus 2 pi n. All right? So then we're going to do the same thing in 5 through 7. We're going to come up with the general solution first and then the first 3 positive values. So arc cosine negative, so this is going to be in the second quadrant. The adjacent is negative rad 3 over 2. Hypotenuse, that's 1. So the reference angle is 30, which means this will be 150, which is equivalent to 5 pi over 6. Pi over 6 is 30. 30 times 5 is 150. So I start off with my general, which is plus or minus 5 pi over 6 plus 2 pi n. That's your generic. Now we want the first 3 positive values. So I have a negative 5 pi over 6, and I have 5 pi over 6. And if I add 2 pi, I want to have a common denominator. So 2 pi is the same thing as with a denominator of 6, 12 pi over 6, because 12 over 6 would reduce to 2. That makes it easier to add. So I'm adding 12 to each numerator. So this becomes 7 pi over 6, and 12 plus 5 is 17 pi over 6. So my first 3 positive are these 3. So we would write it out as x equals 5 pi over 6, 7 pi over 6, and 17 pi over 6. Now if I have the negative 1/2, again that's negative, so it's going to be in the second quadrant, negative 1 over 2, that makes this a rad 3. So this is a 60-degree reference, which makes my angle 120, which in radians, 2 pi over 3, because pi over 3, 180 divided by 3 is 60, 60 times 2 is 120. So my general is plus or minus 2 pi over 3 plus 2 pi n. And again, we want to find the first three positive. So I have here negative 2 pi over 3 and positive 2 pi over 3. And if I'm adding 2 pi, we need it as a common denominator, a denominator of 3, so this will be 6 pi over 3, because 6 over 3 reduces. So now I'm adding 6, so this will become 4 pi over 3, and this will become 8 pi over 3, and here are your first three positive values. So this will be x equals 2 pi over 3, 4 pi over 3, and 8 pi over 3. And then the last one we have is positive rad 2 over 2, which is a 45-degree reference, because that's equivalent, that's your rationalized version of 1 over rad 2. So the general would be plus or minus pi over 4 plus 2 pi n, and then finding the first positive. So I have negative pi over 4, positive pi over 4. I'm going to be adding 2 pi each time, so we need a common denominator with 4. 4 times 2 is 8. So that gives me, I'm adding 8 pi over 4. So this will become 7 pi over 4 and 9 pi over 4. And those are your first three answers. So we have x equals pi over 4, 7 pi over 4, and 9 pi over 4. All right, so now we have to do a little work to isolate. So we're going to divide by 2. So that's gone. Then we're going to take the arc cosine of both sides. So arc cosine of negative rad 3 over 2 equals 2x minus pi over 2. And the general solution for this, if you look up above, that's what you came up with in number 5. So that's going to be plus or minus 5 pi over 6 plus 2 pi n equals 2 times x minus pi over 2. So we are going to multiply both sides by 1/2. You have to distribute to everywhere. So this will become plus or minus 5 pi over 12 plus just pi n, because the 2 and the 2 will cancel, equals x minus pi over 2. So I have to add 5 pi over 2 to both sides, and I'm going to continue over here. So now pi over 2 is not a common denominator with what we're doing. So I'm going to rewrite pi over 2 in terms of 12. So that would be 6 pi over 12, because 6 over 12 is the same as a half. So my general solution, 6 plus 5 is 11 pi over 12, and 6 minus 5 is just pi over 12. So up here for my general solution, I've got 11 pi over 12 plus pi n and pi over 12 plus pi n. Now that gives me two positive answers already. So to get my third answer, I'm now only adding pi, but here, let me do the little table so you can see how this works. So if n is 0, I'm starting with pi over 12 and 11 pi over 12. If I'm adding just pi, because that's now our period, pi is the same thing as 12 pi over 12, so I have a common denominator. So this becomes 13 pi over 12, and now I have my first three positive values. So pi over 12, 11 pi over 12, and 13 pi over 12. Those are going to be your first three answers. Now this last one, we're going to do it in degree mode. And on the test, I will allow you to do whichever mode you want, but just be consistent. So that if you're going to do degrees, you're adding 360n. If you're doing radians, you're adding 2 pi. So first thing I did was divide by 4, and so that's a negative 1/2. And then I have to take the arc cosine of both sides. So I get arc cosine negative 1/2 equals 2 theta. And in number 6, you do have the general solution to this. So this is plus or minus 2 pi over 3, because it comes from the second quadrant since it's negative. Oh, silly me, look at me. I just said we're doing degrees, and here I am going into radians. Sorry about that. So that's going to be 120 degrees plus 360 n equals 2 theta. And then we will divide everything by 2. So your general solution is plus or minus 60 plus 180 n. And to come up with my first 3 particulars. So I had negative 60, positive 60, and I'm adding 180. So this will become 120, this would become 240. So my first 3 positive are going to be 60 degrees, 120 degrees, and 240 degrees. So now you can use a calculator, and we want to find the first 3 positive of cosine 0.6. So we're looking for arc cosine 0.6, which is plus or minus your inverse cosine plus 2 pi n. So we go to the calculadora, make sure you are in radian mode, and the inverse cosine of 0.6 from the calculator is 0.93, so plus or minus 0.93 plus 2 pi n. Now 2 pi is about 6.28, so when I'm finding my first 3 positive, I've got negative 0.93, positive 0.93, and I'm adding 6.28 each time. So 6.28 plus 0.93, this will give me 7.21, and above it I've got 6.28 minus 0.93, 5.35. So here are my first 3 positive values. So x equals 0.93, 5.35, and 7.2. That would be your first 3 positive values. Okay, so now we're given a graph, and we want to come up with the equation. So notice I have a high here of 6 and a low of 2. So 6 plus 2 is 8. 8 divided by 2 is 4. So my sinusoidal vertical shift is going to be at 4. My amplitude is going to be 2, and I'm going to come up with the equation of this particular cycle. My period is from 10 to 90, which is a distance of 80, but remember that's not what goes in the equation. B is going to be 2 pi over 80, which is pi over 40. And my phase shift is going to be starting at 10. So putting that all together, y equals 4 plus 2 cosine pi over 40 x minus 10. And now here's the equation y equals 5, and it wants me to come up with a general solution for where these points of intersection occur, and then I'm going to come up with the first 3 positive, which is going to be this one, and this one. All right, so we start off with 5 equals 4 plus 2 cosine pi over 40 x minus 10. So I'm going to subtract 4, and that's going to give me 1, and I'm going to then just go ahead and divide by 2, right, just to kind of hurry up the process a little bit. Pi pi. So you're always just subtract and divide those first two steps. Now I'm going to take the arc cosine of both sides. So we have plus or minus the inverse cosine of 1/2 plus 2 pi n equals pi over 40 x minus 10. So what I kind of skipped was I took the arc cosine of both sides and then used the definition. Now we have to evaluate the inverse cosine of 1/2. At this point you have a calculator, so even though that is an exact value, you're totally fine. So 1.05 plus 2 pi n. And then we are going to be multiplying by 40 over pi. So 40 over pi gets distributed, so that would then equal x minus 10. So 1.05 times 40 divided by pi on the calculator, that gives me plus or minus 13.3 plus, now this 40 over pi has to distribute, so that gives me 80n. You should get back your original period equals x minus 10, and last thing is to add 10, but remember this is 10 plus and 10 minus. So my general solution is going to be 23.3 plus 80n, and it's going to be 10 minus 13.3, which is negative 3.3 plus 80n. And to find the first three positive values, I'm going to set up my little table of values. I realize I didn't give you much room here. So I have negative 3.3 and 23.3, and I'm adding 80 because that's my new. So this will be 103.3, which makes sense. This one's the 103.3. If I do 80 minus the 3.3, that gives me 76.7, which is this one, and 23.3 was from my original, so there's my first three positive. So I've got 23.3, 76.7, and 103.3. All right, now at the bottom, we have a giant Ferris wheel is 60 feet in diameter, and it completes one revolution every 4 minutes. That means it makes one cycle. So that's basically your period is going to be 4. Sketch a graph of the height a person is above the ground t minutes after boarding. Assume the closest a chair gets to the ground is 2, because otherwise you die. So if you're starting at a height of 2, that means the highest point is going to go to 62, so that you have the full diameter of 60. Halfway between is 32. And we're going to assume that you're getting on at the low point, so that's going to be at time 0. 4, is it minutes? 4 minutes, that's kind of a slow ride. 4 minutes later, you're also going to be, because it makes one complete revolution every 4 minutes. So at 2 minutes, you're going to hit the high. And at 1, you're hitting your sinusoidal, and at 3, you're hitting the other sinusoidal. So there's your 5 points. So writing a function for this, we have our vertical shift, our amplitude, our period, our phase shift. So 32 is your sinusoidal. Your amplitude is half of the diameter, but this is a reflected graph because we're starting low, ending low. The period is 4, which means B is 2 pi over 4, which is pi over 2. And we're going to start at 0, which makes it an easier problem. So y equals 32 minus 30, since it's reflected, cosine, pi over 2 t. That would be your equation. How high, so we're trying to solve for y when the person is 5 minutes above. So we're finding y of 5. So that's 32 minus 30 cosine pi over 2 times 5, which is 5 pi over 2. And I just enter that as it is on my calculator. So you should realize cosine of pi over 2 is 0. So when I enter this on my calculator, I should just get back 32. All right, I hope that helps.